Welcome to Photon IIT Academy. In this session, let me discuss the solutions of the previous session. In the previous session, I have given some quantities. Let us see those quantities one by one. The quantities given are, first one is power. Power, it is defined as work or energy by the time. So already we know that work is force into displacement. That is the force into displacement. This is displacement. And in the denominator, it is the time. Here, the force dimension formula is mass into acceleration, ml t minus 2 power to the t minus 2 into displacement is dimensional expression is L, time is T, time is T. So here L into L, L square. So M L square T minus 2 is the work dimension formula divided by the time T. So power comes to be M L square if this T comes upon in the numerator side, it is T minus 3. So this is the dimension formula for the ml square T minus 3. Observe this. By making use of the dimension formula, we can write a unit. If you want to express the power in terms of the unit, observe this. This is M. M is kg. So kg. L. L is a hyphen. L is length. So meter square. And in the denominator, t to the power of 3. So second. So this is the unit for the power we are going to express. So here, when you want to take up the power, in terms of the standard units, observe this. Previously we have expressed work as the unit of the work is joule, and this is time is in the second. So you can express the work is joule per second also. So this can be joule per second also. Joule per second. Observe this. This is the force. The unit of the force is Newton. So this is the unit of the force is Newton. And displacement is meter, Newton meter. And time is second, Newton meter per second. We can express in terms of the Newton meter per second also. By observing these three things, power can be kg meter square per second cube, and another unit is joule per second, and another one is Newton meter per second. Observe here, the standard unit of the power we are going to express as the watt. It is watt. That means 1 watt is equal to 1 Newton meter per second, or 1 watt is equal to 1 joule per second, or 1 watt is equal to 1 kg meter square per second. This is the overall expression of the power. Let us see the another one. The second one is, we have seen the pressure. So pressure is defined as normal force per unit area. Normal force per the unit area. What is the dimension formula of the force? Mass into acceleration. ml t minus 2 divided by area L square. Area is L square. Force is mlt minus 2. Area is L square. That is equal to m. One of the L in the numerator and denominator will be cancelled. So L to the power of minus 1. T minus 2. This is the dimension formula for the pressure. Observe this. And if I want to put up this in the units, mass is kg, and this is L is, that is the in the denominator, meter. T is second, so second square. So kg per meter second square. Kg per meter second square is the unit of the pressure. And you can also mention this pressure in other units also. What is the general unit of the force? Generally, we are expressing force as Newton. And area, meter square. L square is meter square. So pressure can also be expressed as Newton per meter square. And this Newton per meter square, 1 Newton per meter square, can also be called as 1 Pascal. Observe here, the standard unit of the pressure is Pascal. And 1 Pascal is 1 Newton per meter square. Similarly, 1 Newton per meter square can also be expressed as 1 kg per meter second square. You can either go for this or this or this. All are the expressions which are dealing with the pressure. Let us look for the previous third exercise I have given. Pressure gradient. Pressure gradient. Pressure gradient I define is change in the pressure within certain distance dp by dx. Just now we have seen the pressure. Simply we can write pressure by the distance. Pressure by distance. That is the definition. What is the dimension formula of the pressure? Pressure is force by area. You know, force by area. Force by area. This is the pressure, normal force by area. Distance is length L dimension. Force is here. I put up the force is m mass into acceleration mlt minus 2. Area L square, L into L square. Denominator, again, this is L. So one of the L will cancel. So pressure is equal to M and L. If it comes up, L to the power of minus 2, T minus. This is the dimension formula of the pressure. Force, MLT minus 2. Area, L square divided by length L. So one of the length will go out. So M, if this L comes up to the power of minus 2, T minus 2. This is the dimension formula for the pressure gradient. Observe this. If you look at this pressure gradient, you can express this pressure in terms of the simple units. What are simple units? kg, mass is kgs, per L is meter, meter square, and second square, meter second square. This is a simple expression. However, you can also express this pressure in terms of the other also. Pressure is just now I have seen Pascal. Newton per meter square is Pascal. So here observe Newton per meter square is the Pascal, is the pressure. Divided by the length is L, that is the meter. So that means you can simply write this as Newton per meter cube. This is the unit for the pressure gradient. This is the unit for the pressure gradient. Hope you understood. The another last one in the exercise is surface tension. Surface tension. This surface tension is expressed as force per unit length. Force per unit length. The force mass into acceleration mlt minus 2 and divided by length L goes out. So mt minus 2. This is the dimension formula for the surface tension. Dimension formula for the surface tension. Yeah. So simple expression of the unit is mass is kg and that is the per second square. Time is the second. kg per second square. And in another manner, also you can express that is what is the force? Force unit is Newton and length is meter. Newton per meter. This quantity can also be expressed in terms of the Newton per meter because force is Newton and length is meter. Newton per meter is the surface tension. Clear? So previous all the exercise, whatever I have given, I have completed. Let us see the new quantities that are here. Let me take up one by one. First one is that is the angular displacement. Angular displacement. Observe, this is simply denoted as theta. So let us say that this is a circle. This is a circle. There is a center. And this is the radius, and here there is a particle moving along the circumference and moved up to A to B. This is the arc, and the angular displacement is theta. Center is O. So from A to B, it has moved an arc and through a radius of this way and displaced how much theta is displaced. OA to OB is the displacement. OA to. So here the angular displacement theta is expressed as, that is the arc length, arc length by the radius. Arc length by the radius. What is arc length? AB. It is a length. What is radius? OA. OA is also a length expression. So L by L. Length is expressed as L, dimension formula expression. Radius is also in terms of the length units. So L goes. There is no dimension at all for this. So that means if I want to write m to the power of 0, L to the power of 0, T to the power of 0. This is the dimension formula. Anything to the power of 0 is 1. 1 into 1 into 1, it is simply 1. So this is the dimensional formula expression. Okay? Observe this OA to OB is the moment with a AB is the angular way. Theta is the displacement. So let us see the second one. That is, second is, here I take up angular velocity. Angular velocity. Angular velocity. We denote it as the omega. Omega is defined as, what is the linear velocity? Linear velocity is linear displacement by the time. Similarly, angular velocity is angular displacement, angular displacement by the time, angular displacement by the time. So what is angular displacement? From the previous expression, no unit. Dimension formula is, that is the no dimension formula, that is 1 divided by time t. So it is expressed as t minus 1. Okay, t minus 1 is the angular, the velocity expression. Observe here, when you take up this one, you can write in expanded form m to the power of 0, L to the power of 0, t to the power of minus 1. This is the general expression. Clear? And here only I would like to put up, that is, what is the unit of this? Unit of this is expressed, unit is expressed as, its unit is per second. So 1 by second, because t in the denominator, 1 by second, second inverse, second inverse per second also. It is also called as per second, per second. Okay? Okay? Now, let me put up the third one. That is, third expression is, here I take up the third expression. Angular acceleration. Angular acceleration. Denoted as alpha. Denoted as alpha. So alpha is angular velocity, rate of change of angular velocity, d omega by dt. Rate of change. What is the linear acceleration? Rate of change of velocity with respect to time. Angular acceleration is rate of change of angular velocity with respect to time, or simply omega by time t. So here, when you look up for this, alpha is equal to angular velocity. Just now have seen dimension formula, t minus 1 by the time denominator is t. So it is t minus 2 e to the power of minus 2, or simply m to the power of 0, l to the power of 0, e to the power of minus 2. This is the general expression for the angular acceleration. Is it clear? So these are the quantities we have seen, and hope you have understood. Let me use some exercise to you. So exercise is try to find out, find out dimension, dimension formula and unit for the following. Dimension formula and unit for the following. Okay. Here, first one I am giving is charge, electric charge. Second one I am giving torque, torque. Third one I am giving current density, current density. These are the three things. You can go for the exercise, and I will explain in the next session these in detail. Hope you have understood the session, and for the beginning part, I'm going very slowly. Let us go slowly from the basics, then towards the difficult problems. Thank you very much.